Here, just behind me, we see the mating ritual of two Marshall Reissue heads, the last of their kind with diagonal transformers. Well, we hold out little hope for the future of their species. Hopefully they have fun doing it.
Whoa, hang on a minute, what's that? Oh, g'day champions, we're back into it for the new year. Long time no see, at least on edited videos. Got a couple of Marshall reissues here. We've got a 2203 and a 1959 that's been modified. So I'll trace out this modification and we'll figure out what it is. It's not performing well. I've disconnected a wire there to just figure stuff out. So this one here came in with increased hum, suddenly increased hum levels. Now I've tested the cathode resistors. You can see one down there. Panny boy, yeah boy. That little metal film, 1 ohmer down there, and there's another one on the other side, along with a nice little elephant's foot of solder. Honestly, guys, I've got to learn how to solder, eh? It's not that hard. I mean, if I can do it. Anyway, that one's open circuit. This one's okay. And they've got a shared cathode current sense resistor per pair of output valves. So I dare say one of these two valves has gone short circuit and it's taken out that resistor. And that resistor going open circuit has prevented the high tension fuse from blowing. So the other one's continued to conduct half the waveform, resulting in pretty weird sound, reduced output, and no common mode rejection of hum, so increased hum level. So I dare say that's going to be a new set of EL34s. You could probably replace a pair of them and balance them back out, but I'll see what the customer wants to do, what the budget is. We'll otherwise inspect this one and just check that everything's hunky-dory. There's a weak spot in these reissues. The heater balance trim pot likes to arc over when you have a valve failure upon using a Russian valve in the cathode follower position. A lot of info here to take in. Bear with me. So what happens, you put an electro-harmonics in the cathode follower position, it goes short circuit and then takes out that heater balance thing, and then you get increased hum or full-on fire in this area. So the way to do it is just bypass the trim pot altogether and just put in two fusible 100 ohm resistors in its place. This is inexplicable. Unexplicable, I'm inventing words again. This is inexplicable. They've got the trim pot hanging on by one lead still, floating around. That'll probably snap if I bend it 2 more times. They've got 100 ohm there, 100 ohm there as stock, but they've removed it obviously from the trim pot and they've put 100 ohm across them. So now you've got 200 ohm on this side and 100 ohm on that side, so I dare say that's not balanced. Sometimes, like you saw recently in the Vox video I did, intentionally unbalancing them because of the windings in the transformer and whatever. Sometimes that can be optimal, but 2 to 1, I don't know about that. I reckon this is a fuck up. So we'll redress all of this, we'll redo all of this. I'll just put 2 fusible resistors there and we'll assess that that is properly balanced and go from there. So that one's a pretty much known factor, that's all good. I'll flick a quote for that one and we'll get moving as soon as we get approval. This one back here, however, is coming with all sorts of reports. No output, squashed output, reduced power level, like very limited power output in the gain mode. So someone here has drilled another hole for another valve and put a tag board there, which is fine. They've added 2 more gain stages, but now you've got massive amounts of gain and it's oscillating like crazy at almost all settings, except for when everything's turned right down. And there's a diode clipping mod. It's known as what, the Jose mod or whatever, and that's got, it's supposed to have some Zenas, but they've used germaniums. 3 of them in series, so that gives you a forward voltage of about 0.9 volt. So that would be clamping the signal to 0.9 volt, and they put that just before the effects loop where the signal's rather high. So yeah, it clips like fuck, but doesn't supply enough power to the output stage as a result, so it's very, very limited output and lots of oscillation. This shield here, they've used a bit of coax. So essentially this is a super lead stock all the way up to this valve, and they've added more stages before it that are switchable. I'll show you the schematic because I've traced it out because I'm a madman. But from this point forwards, it's pretty much a stock super lead, right? All the boards pretty much unmolested except for their little special heater balance mod there as well, which kind of defeats the purpose. They've cut out the resistors and just put more resistors in. I guess they're fusible at least, but you still got the trim pot issue there. The trim pots can't handle anything going wrong, they just catch fire. So essentially everything from here on stock. We've just traced out this first extra 2 stages. I'll see what special we can do with this, and I'll run you down on the old KiCad, and we'll do a schematic of what the proposed circuit is. I'll test it and we'll have a listen and blah blah blah. Everyone can tell me I'm an idiot. I've talked to the customer, and the plan is to have essentially a 1959 on 2 channels, 1 2, as if you're plugging into the high gain input 1. So that'll change to be like bright normal channel, and then this will be like a 2203 channel. So we can use essentially from the cathode follower onwards, these are pretty similar amps. So if we use the triode here to create the front end of a 2203, you can switch between a 1959, you plug into the normal or the bright channel, or you flick a switch or you plug into the 2203 channel. But I'll figure out exactly what I'm going to do. Nothing at the moment is foot switchable. It all takes like work to turn stuff, pull stuff out, change the jacks. So I don't think this is going to be a live rig. It's going to be a home or recording studio rig. So you might have to unplug and go into the other channel instead of introducing relays and all that kind of thing, because we want to keep it as simple as possible. But anyway, I'm waffling, so I'll come up with the proposed design. I'll run you through it in KiCad. Now these FX loop boards aren't great. They sort of attenuate the signal right down to something an op amp can handle, and then amplify the fuck out of it again afterwards to compensate for it. So a lot of noise is introduced in that process. You can bypass it, which is fine. If the customers don't use them, just bypassing them will do the job. Otherwise, if you want a better performing one, get onto Jase, my mate Jase at Headfirst Amplification, or Evolve DIY, his new branding is. He's got an LND 150 high voltage FET based one, which is really the duck's nuts. So all the drilling and everything, or the component, the jack and the switch locations suit the existing drilling. So it's a matter of just popping one in and connecting her up, son. So looking at this shield over here, it's actually what they call a hot shield. So you can see there, the actual signal line is on the green wire. It's got a green heat shrink on it, and the shield is run to pin 1, which is the anode. Why would you do that? What rating is this wire? Doesn't say anything on it, but would it be like 300 volt rated coax? I don't think so. So that's not a good idea. And then you've got the noisy anode high voltage swing being radiated throughout the amp from that coax. If you're going to do a hot shield, well, you shouldn't anyway. I mean, fuck, it's not hard to find a ground. There's chassis right there, bro. But if you're going to do a hot shield, don't use the anode. Use an HT line, but just don't do hot shields. Just ground it. So that going over here near the inputs might be a source of the oscillation as well. So first thing I'll do, remove the stupid diodes, which I'll show you the effect of shortly, and ground that shield instead of having the hot shield. But just in general, you see both PCBs there say ST1 on them. They're the same board, just different populations. You can see down there it's got the C2s vacant. Over here C2's loaded with the 330 and R21 there, that's 100k. And that's 47k. So that's, I guess, a cost-cutting measure at Marshall initially, and now these reissues just do the same thing that they did back then. But there's no real reason, aside from the extra jacks, that you couldn't turn a 1959 into a 2203 and vice versa, if you were that way inclined. I know guitarists can be like, you know, monkeys on crack when it comes to modding their gear, so yeah, do that. It's if it's snowing where you are and you're bored, turn your amp into something it's not supposed to be. Everyone else does it. So this one's not working. I'm waiting for the quote. This one is sort of working. I'll show you the sound samples and then we'll dive into the schematics. So at the moment this pot's out of circuit, the gain, because you've got to pull it to be on. That bypasses the extra 2 stages, right? So pulling that on, now you've got 2 more stages. Pull that back in and it's pretty well the stock circuit. So that's basically the master is, it's like a 1959 plus a master at the moment. So I'll just turn down the mic there a little. That's a high treble, and then the normal. it's like he's linked the channels. You turn the master down. There's a lot to be said with just a 1959 with a master volume. So at the moment, that's like, I can easily talk over that. Go up to 12 o'clock on the master. So it's sounding okay, but you pull this out. Now there's like no level. And that's master all the way up. And I can easily talk over that. So yeah, that's those silly germanium diodes there. You can do the diode clipping, but use Zeners for higher voltage that they clamp at. So anyway, let's try this gain mod. So at one point there you actually get less gain. Very unstable, kind of useless above 12 o'clock. And it only really starts to add meaningful gain above 12 o'clock, so. Just on the verge of oscillation there. Almost sounds like a microphonic valve, doesn't it? Could be. It's a bit of everything, mate. But essentially that's just uncontrolled gain with no real thought given to the lead dress and stuff. So I think we can do better, champions. So here's a close-up of those pull pots. There's the germanium. I don't know what they thought they were doing there with the clipping diodes. It's not a guitar pedal, but they're the clipping diodes there. Some pretty questionable soldering and just lots of long bare leads floating around as well, which isn't great. At least they didn't use a hot shield on this one though. That's grounded at the pot body. It's almost like two different people did the work, but then you've got the labels on the front which appear to have been printed at the same time. So, don't know. Like, this is relatively well done, but then this stuff's a bit weird. So I don't know. You go crazy trying to figure out other modder brains. It's just best to not try. So this one came in with two of the EL34s pulled to running 50 watt. That's doable. Just check that your voltages and stuff, like, don't just do it and hope for the best. Your voltages will change because there's a different load on the power supply. So get a tech to do it that knows what they're doing, and they'll be able to monitor stuff and just make sure everything's fine and dandy. So a lot of you guys probably already know this, but the way to do this is you pull two of the output valves. You don't pull one side, you pull either the outer or the inner two, doesn't matter which. Now if you had an 8 ohm cab and it was plugged into 8 ohms, turn it to 4 ohms. If you had a 16 ohm cab and it was plugged into 16, switch it over to 8 ohms. So you want to be running the actual impedance of double what it's set on the amp, essentially. I think I got that the right way around. I always forget. People put me on the spot and ask me. I'm like, yeah, let me think for a second. Got a smashed up mains input there, so I might replace that just so it doesn't crack any further or whatever. Got Tube Amp Doctor. I don't think I've seen Tube Amp Doctor on a stock Marshall before. I heard the other day that, yeah, they're using him. What date is this? Ah, so it's a 2015. Interesting. I'm actually building a pair of cute little 50 watt heads as well. I've gone with the Tube Amp Doctor capacitors myself, and I've gone with Hammond iron. It's basically a JTM 45 chassis where I've just loaded the rectifier with another cap. So we've got our 1, 2, 3 caps that would suit a 2203 circuit. Beltons all around. I'm going to put a little trim pot there, you know, the recessed fender style trim pot for the bias there. These are partially a trial run for maybe I'll start a couple of lines of amps and maybe sell a few. See how we're going. I want to do it properly, and it's going to be a bit of a trial run for getting the silk screens on the front and back. This is Silk Screen bloke up the road, Blank Canvas, so they mainly do clothing, but I think they do some signage stuff too, which leads me to think, ooh, maybe you guys have like UV cured inks and stuff. Maybe you might be able to do some silk screening for me. I do like the idea of a silk screen with the big contrast and the fact that you could use different colors. UV printing's an option as well. Even you could use like a high watt style laminate and use a CNC engraver. They're all options, champions. So this is like a trial to see what's the least pain in the ass, gives the best results, and is cost effective. So stay posted for those videos. Hopefully it'll be interesting and not painful. But yeah, we've still got the diagonal on these ones. They've gone to Vietnamese transformers for their reissues these days. There's Jase's video that's doing very well, which I'll link, pointed out. People love a bit of controversy, eh? You got the diagonal choke down there as well. Cute little chucha. Alright, champions, let's look at these schematics. It's Sunday Arvo. The smell of fresh cut grass is wafting in. It's going to be a healthy 37 degrees today. So let's have a look at what I found inside this amp. You've got the two circuits with the normaling and 268K grid stoppers. They put a 1.2K on the valve socket. I guess that's to get some kind of local grid stopping to try and eliminate oscillation. It looks like throughout the amplifier they've gone to some effort to try and reduce oscillation, but the oscillation's been caused by the layout. Pretty hefty 750 pico on that plate supply there. And you've essentially got two stages cascading into each other before the input of the standard 1959 circuit. Got a very significant bright cap there. A lot of weird decisions, like hot shield on the coax. That coax is about 8 inches long, and not only is it a hot shield, but it's attached to this anode. It's not attached to the B+, which you can do, but it's not recommended because the wiring coax, the coax they used, isn't rated for that kind of voltage differential. When you first turn this amp on, that will reach probably 500 volts. So attaching it to the anode has the side effect that you've got the output, pretty high voltage swing here, being radiated by that hot shield throughout the amplifier, which is probably also contributing to the oscillation. And then what they did on the first stage, they've mixed the two channels together, the normal and the bright, by linking those two grids. From that point forward, it's pretty much a stock 1959. And down here, here's the silly germanium diodes clipping what should be probably a 20-30 volt peak-to-peak swing there, clamping it down to probably about less than a volt. So yeah, in theory that works, but that's like for a pedal, like a guitar pedal, where this amplification stage is happening afterwards. This just goes to the effects loop where it's heavily attenuated and then re-amplified afterwards because they use an op-amp there. And that, if it's not bypassed, goes to the phase inverter input. So there's no real significant gain after this stage. So that's why we're only getting a couple of watts out of it when the diode clipping is engaged. So what I'm proposing, here's a little sketch I've done in KiCad. Essentially that's the normal channel and that's the bright channel. This is just showing indicative of what's existing in the amp, but if you were to build this would work as well. And then using that extra two triodes, that extra valve, I've called it VOA and VOB because V1 and V2 are part of the existing circuit. That's basically the front end of a 2203. Now I've got some switching here to boost the gain a bit. Well, you know, get it to clip more. And then that mixes back in at this point here. So you can think of the 470K there and the 470K there as mix resistors as well as attenuator. So I've done this before and it works rather well. I'm also going to, I haven't drawn it yet, but I'm going to put some diode clipping there, but I'm going to use Zeners. So it clamps at a reasonable voltage, not at like 1 volt. So you'll still be able to get full output swing. And we are going to leave the effects loop in. If it's not being used, you can just hit the bypass switch and it's out of circuit effectively. So there you have it. That's the plan. Some of these values, I've just plopped components in there. I haven't refined all the values and everything yet. But yeah, we'll see how this goes, and hopefully it's going to be a lot better than it is. I might also do a resonance mod, like a depth mod. Might do that, just a preset pull switch that will just engage the depth cap in the feedback loop to give it a bit more balls and bottom end. And everyone I've done that for has really enjoyed it and thought it was amazing, and the things never sounded so good. So it's something that can easily be reversed, however, if it's not to the user's taste. So I'll leave this one here, champions. Stay posted for the next video where I show you the results of our evil plan to take over the world. Same thing we do every night, Pinky. Until then, rock on.